Hello, everyone. This is Trisha Ramsey, and on behalf of Cast AI and 451 Research, which is now part of S&P Global Market Intelligence, I would like to welcome you and say thank you for attending today's webcast titled Disaster Prevention in the Age of Multi-Cloud. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen. We will get to as many as we can during the Q&A session. The presentation slides are available for download in the resources section in the console. And finally, the on-demand version of the webinar will be available for download once the live event concludes. Leading off today's discussion will be Henry Baltazar, who is Research Director at 451 Research. Joining Henry will be Leon Kuperman, who is co-founder and CTO at Cast AI. Also joining us is Fausto Lindenberg, who is co-founder and CEO at Egress. And with that, I'll turn it over to Henry.
Thanks so much, Tricia, and thank you all for joining us today for today's roundtable presentation. Before we kick off, I'd like our participants to give a quick minute or two introduction to themselves and their backgrounds. Let's start with you, Leon.
Hi, everybody. My name is Leon Kuperman. I'm a co-founder and CTO of Cast. So been in the industry for quite some time. Really started my career in application development and e-commerce specifically. And as time devolved into cybersecurity, most recently, I was with Oracle Cloud, working on their cloud security platform. And Fausto, you want to introduce yourself?
Yeah, thank you, Leon. Thank you, Henry. My name is Fausto Lindenberg, CEO of Egress, and I've been in the industry well, 15 years, completely focused on cybersecurity. So everything from infrastructure security, cloud security, and spend my time just really building resilient infrastructures and helping the enterprise really build something stable that can scale.
And my name is Henry Baltazar. I'm the Research Director of Storage at S&P. And I've been covering storage and data protection for the better part of 20 years now, which is way, way, way too long. But today's topic is really interesting to me because it's really an intersection of all the interesting things that are happening today. Disaster recovery continues to be a huge issue for many organizations. And when you start adding in the complexity that comes about from going into multi-cloud environments, and also where we are going with cloud native and the container space, there's definitely a lot of challenges that are getting even more difficult. And I'm really glad that we have this panel today to discuss this and look at this both in multiple formats in terms of looking at this from a cloud perspective, from a security perspective, and also from the container perspective for cloud native. For today's agenda, I'm going to kick things off with just a couple slides in terms of what we're seeing in terms of disaster recovery trends. And then after that, we'll be going directly into the roundtable discussion. As far as some of the top trends that we're seeing, the top pain point for many organizations continues to be data capacity and growth. And that's something I continue to emphasize because it's no secret. As we have more and more data, that makes every other problem much, much worse going into the future. But disaster recovery has always been a huge issue for many organizations, and it's almost always a top one or top two issue when we talk to companies about what they're trying to deal with on an ongoing basis. And there's good reason for that. When I start looking at our most recent survey, which came out of the field this quarter, we had about 30% of our respondents that reported that they had an outage just within the last 2 years, with 17% saying they had something in the past year, and another 14% saying that something happened 2 years ago. More likely than not, your organization is going to suffer through outages or deal with an outage sometime in the future. So it's definitely critical. No matter how well designed you are, as we'll talk about later, there's a lot of things that can create outages, and we need to be careful and make sure we're doing our best job to be proactive in terms of how we deal with the outages and, more importantly, how quickly we can recover from them if something does happen. When we start looking at these outage incidents, there's no surprise. A lot of them have wound up being very costly for customers. In the most recent survey, we had 11% of them saying that an outage, their most recent outage, cost them over $1 million in cost, which is up from 7% a year ago. In that range between 100,000 to 1 million, that went from 42% to 50% in the most recent survey. So a lot of these outages are happening, as we talked about, happen frequently, and they can be quite expensive for organizations, especially if they're not ready to recover quickly from them. And the other thing we looked at is what actually happens when there's an outage. And no surprise, there is lost workload, worker productivity. 51% of organizations were hit with that, which is very significant. But what I'd also point attention to, and also lost data, which is also a logical consequence of this itself, 37%. But I would notice there's a lot of other business things that get very impacted severely when there's an outage. If there's a lost revenue and missed revenue opportunities, that was 26% of respondents. Damage to the company reputation, 22%. Loss of customer loyalty, 17%. Penalties for compliance, 14%. And if you're an IT person, well, 15% said there was employee termination. So there's definitely things that we have to worry about for an outage. There's a lot of business consequences beyond just losing data and not being able to fulfill these other type of transactions, which makes this problem more and more critical for organizations. And last, I think the other thing to take a look at is there's many causes of outages here. As you can see from this chart, none of these different elements wind up being the lead. You have to worry about a lot of these different things. I mean, hardware failure was the lead at 32%, but not by a significant margin over software failure, which is 33%. It was 30%. But as you look here, there's all these other issues that we have to worry about, whether it be security with 30% of respondents there, the network failing, or also the things like human error and facilities and things like that. The thing I'd note here is when we look at a lot of these different categories, a lot of these categories are going to be things that we can help and fix, because a lot of these things are related to change management. And as we start looking at the rapid pace at which these cloud environments, especially the multi-cloud environments and cloud-native type environments with containers are changing, it's clear that we have to do a much better job of compensating for that and making sure we're prepared for that, because the old days of having a mission-critical application that you sit there and you test once a year for disaster recovery testing, it's not like that. We're constantly changing, constantly evolving these workloads, constantly adding patches, and any of those changes could wind up throwing a wrench into what we're doing on the recovery side. So as we talk about that, I think we'll get into the next section here, which is really the core of our panel, which is beyond what we could be doing to help and improve our recovery options and build resiliency for our cloud-native environments. With that, we're going to kick it over to the speakers today, and let's kick off with the first question here. Let's start off with current challenges. And so one of the things that we're saying is, in terms of current challenges, what are some of the current challenges your customers are facing when trying to improve the resiliency of their environments? And for this, let's start off with Fausto first.
Well, Harry, that's an interesting question. I mean, if you think about what is the enterprise trying to do, which is a true digital transformation, which is how can we make sure that our consumer within the industry that we compete, talking from an enterprise perspective, how can we obtain the consumer? How can we make sure we can retain the consumer, which is bringing velocity to the enterprise? So they're rushing into the cloud. They're rushing into a multi-cloud setup because they have multiple teams just building multiple applications at the same time. And that high rate of change is the one bringing high complexity. I think the first thing to really understand, we were working with an enterprise and they were selecting a cloud that they were going to put their consumer space, their consumer business, and then their operational IT business. And they selected GCP for one and Azure for the operational. But before they actually, after they did the planning, then they started building the team, which I think is a big issue and challenge they're having, which is they make deals with the cloud providers and then they go out to the marketplace to find talent. And that skill set, there's a gap in skill set. You probably selected a cloud and now you can't find the talent to really support because of the complexity of that specific cloud, or you just don't have the resource in-house. So, you signed the deal and now you're really stuck in the middle with this multi-million-dollar, multi-year contract. Right. So the first challenge they're having is finding the right skill set that it's aligned with their planning as they go multi-cloud. And it's something they have to be completely aware of. I think the second challenge, with this velocity is there's a saturation of tooling, right? Every single cloud provider has a different set of services, a different way of those things working. And sometimes either do you go cloud native, do you go third-party tool? And I think this amount of tooling is saturating the same talent that you have in-house. So there's a combination of how do you maintain velocity through digital transformation, not introduce any risk into your environment, but how do you have the right people in order to really overcome these challenges? And they need to be cloud agnostic, which is super difficult to find in today's world. So the big thing is to be aware of the entire journey. So analyze the entire journey, your multi-cloud, select your stack before you even write the first line of code, because there's a lot of challenges down the road.
Yeah, I think you're 100% right. I mean, everything you laid out, massive OpEx challenges. And you can't just, we can't afford to throw people at these problems anymore. I mean, budgets aren't unlimited. And even if you had unlimited budgets, it's hard to find people with all these different skill sets. And even if you have the people, then you have the issue with all those tools, which tools to use, which ones to train on, it's a very difficult problem. And that just shows that we have to do much better planning and how we deal with these things going forward. What about for you, Leon? What are you seeing in terms of these big challenges?
So Henry and Fausto, thank you for bringing up the skill question. I think that's a really important point to drive home. We just don't have the humans in our industry to help cover all of the challenges that we're seeing. But let me step back and kind of take a look at the patterns that we're seeing when customers are kind of deploying highly available applications, but they have to kind of span those cloud boundaries in order to have those applications available. So let's use the example that Fausto gave, where we have a particular set of apps in cloud A and then another set of apps in cloud B. And this is what we call the A or B pattern, where you're not necessarily deploying the same application into two different environments. So those two environments are not actually helping you with high availability. They're likely hurting your availability. And I'll give you a concrete example. If you take like the IT-based applications that kind of the organization needs to run that are running maybe in Azure, in Fausto's example, and there's some dependency for the consumer-facing apps that actually need those microservices or services from Azure. If there are any issues with the Azure environment, or the cloud goes down or the app goes down, all of the issues in Google will domino effect, and you will have an entire set of outages, right? So one of the core challenges is when you have this kind of distributed application in different cloud environments, there is a severe risk of domino effect where a failure in one cloud can actually domino and affect all your applications in other clouds. So we call that the A or B problem. And that's one of the things that we're looking at solving kind of in the short-term future, which is how can we build a highly available application that leverages the resources of not just one cloud environment, but multiple cloud environments.
That's great. As I mentioned earlier in the preamble, change management is becoming a big issue, and the high velocity of things happening. Anything you're seeing on your side, Fausto, especially in security, where they have to react so much to all these different changes and other things that are happening?
Yeah, I think there's two major areas here, not that Leon has brought up home as well. One is technology are being built from a developer-first approach, right, which is a bottom-up. And I think it's a very mistake, because it's very hard to translate risk all the way to the board when you start within your own silo, within your own application, right? So security needs to be flipped upside down, and the business must be empowered to understand the application layer, to understand the underlying complexity of the cloud, right? For the first time, I think we're changing that paradigm where we want to be able to empower the business to make security decisions across the stack. Right. So some of the complexity we see in today's world is developers are introducing risk into a complex environment. And that multi-tenancy that they build is actually a silo. It's just a bunch of silos making changes. And once it gets to the top, it's almost impossible to govern, right? So governance is a big challenge. The second thing on a complexity in a multi-cloud is there's no cost transparency. And it's something that, we definitely want to drive home in today's thing is, they're building fast, but there's no controls. There's no really smart way of really cutting down the cost. And he's making a huge dent at the enterprise financial level, right? So they sign these big deals. The clouds are never going to stop you from building. That's how they make money, right? And, sometimes the ROI on what you're building and what applications are you hosting, it's not being driven by revenue. And I think from a business perspective, we need to make sure that we understand what the business is trying to do, enable the business, and really start looking at a cost transparency and understand the ROI. And so, the enterprise has a very, very tough road ahead, but they're getting out of this mess.
Okay. Anything to add on that, Leon?
Yeah, so Henry, and I'll just kind of build on Fausto's example. Like change management is a very interesting problem because it both aids and impedes velocity. So the legacy change management approach of change advisory boards and lots of gates between a line of code and production is a real problem, because the way enterprises used to approach this is we'll create lots of gates, and then by the time code gets through all those gates, we'll have some assurance of compliance, we'll have some assurance of transparency, and we will also reduce our risk. But in fact, what we're finding is that's the opposite of that is true from a change perspective. And now more than ever, that developers and engineers are writing infrastructure as code, we're now introducing kind of this change process through infrastructure as code at even a higher risk level. And here's what I mean by that. When you bunch up a bunch of changes in your organization, let's say it takes you a month to release an application or an update to an application, you have now compiled a month worth of risk into that bundle. And it doesn't matter how many people you have looking at it, if you don't have larger changes are generally associated with larger risks. And that's true for the application, and that's true for the underlying infrastructure for the application. So the counterintuitive argument is you should do changes more frequently. The reason why you should do those changes more frequently is because changes that hurt should be repeated. And so in the process of repeating those changes, you as an organization will find ways to automate and test your changes so that they can truly achieve high velocity. And to Fausto's point, like just to go back to the transparency from the board level down perspective, if you bundle up lots of changes together and push them into a cloud environment, whether it's a single or multi-cloud, you are in fact introducing a tremendous amount of unweighed risk into that deployment versus an approach where you have a very clear path from one single change to production, and you might release 10, 15, 20 times per day, and that's what we do at Cast as an example. But every one of those changes goes through a rigorous automated test process, and most importantly, if a change fails, it can be rolled back easily, and you're constantly exercising those rollbacks. And this is, Henry, where I think cloud native has really been able to up the game in the performance of the way folks execute changes. And there's some features built into Kubernetes like rolling deployments, no downtime upgrades, green-blue deployments using canary testing. These are all modern DevOps structures that really aid in the reduction of risk associated with change.
No, that's a great response. Thanks. Let's get into the more practical recommendations in terms of how we're dealing with these issues for improving our disaster recovery and business continuity. And one of the key things we're always thinking about is how do we make sure we can avoid single points of failure? So that's one of the key things we have to fix for the first point. I mean, and one of those things we have to think about, especially with that planning. When we start looking at these things, are there any particular areas of vulnerability which have created outages for your customers in the recent past? Let's start with Leon on that one first.
Yeah, so we've had unfortunately, we had a couple of great examples because we've had some spectacular cloud failures as of late. So let me just give you, Henry, a couple of examples. So we had a e-commerce provider, so someone who's selling goods to consumers. It's a business-to-consumer application, and they had regional traffic failure. So because they were hosted in a kind of a central place in US East, which happens to be a hot spot for where a lot of folks are hosted, regional traffic routing failures, and it could be for a number of different reasons, anything from kind of BGP failure in the routing protocol to a line cut, frankly, just a physical line cut. If you're single homed in that region, your application is going to be down, and there's not much you can do about it. And the problem with e-commerce as an industry is your business is global. If your hosting is regional, you've got a real disconnect between where your customers are and where your single point of failure for infrastructure is, if that makes sense. And maybe I'll just give you one more example. We had a customer in the data analytics space, and again, we had a similar problem, except it wasn't traffic-related issue. We had, because it was a data analytics company, they really rely on the availability of their data to do their work. And by not having kind of a distributed data model where they had shared nothing architecture for the core of the data lake that they need to get to, if access is cut to that data lake because maybe the database is down or there are other issues, it doesn't matter if there's a cold backup and restore, the customer was down fundamentally. And it was due to that kind of lack of highly available distributed data architecture. So those are the kind of couple examples I would leave you with on the risks associated with single point of failures.
Oh, it's all great. How about for you, Fausto? Are there any particular single points of failures that you're helping to advise on the security side of this?
Yeah, I think one of the big things people sometimes and often overlook is third-party providers of services that can impact you. And I'm not talking about just specific cloud today, right? You know, and it happened to me 5-6 years ago. I remember we were, building an entire infrastructure, digital transformation, and because we live in the API world where everything is an API and you have multiple APIs and HA, load balance. And at the end of the day, an API is just a URL. And that URL, before you can actually get the IP address, you need to query a DNS server. Sometimes enterprises are building a very robust multi-link, multi-cloud, multi-API infrastructure, but they forget the DNS piece, the layer before the traffic gets there. And I remember a time where we were hosting our DNS zones and files and in a third-party provider that wasn't resilient enough. So I think if that DNS goes down, which happened to me in my career, now your entire business is at risk, regardless of the multi-tenancy and all the resiliency that you've built now. And it's very hard to get out of that because DNS takes 24 hours, sometimes 48 hours to propagate those changes, right? So I think we need to start looking at third-party risk when it comes to disaster and reliability. You're hosting internally, you have control most of the stuff, but even like a DNS provider, make sure you also have a backup to any third-party company and any third-party tool that you're using. So
yeah, I 100% agree with that. I mean, simple thing like DNS, people want to outsource, but if that's down or if Active Directory is down, it doesn't matter what you do on the application side, you can't even access it. So it's terrible problems that can happen if you outsource these things that are supposed to be outsourced because they're not supposed to be strategic. But how about for you, Fausto? On your side, what are you thinking about in terms of some vulnerabilities that organizations should be aware of in terms of trying to, and the risk that could happen if they rely on a single vendor?
So Henry, was that question for me?
I mean,
sorry, that was for Leon. My fault.
Leon,
the question being on what are some of the risks you're seeing in terms of relying on a single vendor and what the consequences?
Yeah, Henry, let's use a really fresh and painful example. And what I'll do is let's reference the OVH hosting and cloud provider where they had a massive fire in Strasbourg. that caused all of their customers to go down. Basically, that entire set of infrastructure is no longer available. And in fact, the company, OVH, has declared they're not even going to rebuild that data center. They're going to try to salvage whatever server capacity they have and move it to another data center that they operate, which is in proximity. But here is the key risk. Those customers lost data, and data loss, if you don't have the proper data architecture and the proper resiliency for the data, which is the gold really in all of our businesses, the consequences could be severe. It could take days to recover. It could take months to recover. And in the case where there was a single point of failure for the data for these OVH customers, those customers are basically done. Like, I don't know how they recover from their predicament. So if I could only highlight kind of one massive risk from single vendor services, I would suggest that data loss is probably the most stringent and dramatic risk that folks need to be looking at. And in fact, OVH made some announcements after the fact that they're introducing free backup and recovery, but that's all after the fact and for naught if you're the customer that lost all of your data in that disaster.
I think in the prep call, you also mentioned something on cascading outages and the threat there. What else are you seeing in regards to that?
Yeah, Andrew, that's a good point. Fausto, do you want to take that one, or do you want me to take it?
Go ahead. No, go ahead.
Yeah. So cascading outages are an interesting problem because, and Fausto kind of gave one interesting example, which was single point of failure DNS. But one of the things that we noticed kind of in a separate, unrelated incident, and this happened a couple of months ago at AWS, is the cloud services are so complicated that it's hard to understand the dependency graph between the service you're using and other services that might be required for that service that you're using to stay up. So I'll give you an example. We had several customers down as a result of a Kinesis outage in AWS in the US East. Now, some of those customers were not even using Kinesis, but the problem is the services that they were using did rely on some form of Kinesis dependency. So you may not even be aware of what we call service killers, like, hey, these are the things that I'm depending on upstream from my core service, but they will come back to kind of haunt you if you haven't done the proper planning. So Kinesis is just one example of a domino effect, but there are many others that are equally as painful.
I think those are great points. And as we've established, the way to avoid the single points of failures is make sure you're doing, if you can, do a multi-cloud environment. If you can, make sure you're choosing the most resilient third parties. But as we start looking at these, the footprint and how much bigger and how much complex that virtual infrastructure becomes, for Fausto, I mean, the question is, what do we have to start thinking about in terms of how do I secure this now? Now you're adding more complexity, adding more components. What are the things we need to think about on the security side to really deal with this on a multi-cloud environment?
Yeah, I mean, Henry, let's start thinking, let's talk about cloud journey, right? And it's one of the things I speak to all of my enterprise customers, which is every single enterprise in the world is in a cloud journey. And that cloud journey is never going to be done, right? So it's all about, where are you in your cloud journey? Are you at the very beginning of your cloud journey? Are you in transition of your cloud journey? Are you, with multiple complexity? And we can't stop the velocity to really plan this the right way. So it's about adopting the tools that can adopt the complexity of your environment. It's super important to understand. When you're evaluating the tools, you need to really adopt the tools that can adapt. It's all about adaptable security, adaptable automation. So one of the big things is you look at the cycle, the DevOps cycle. We understand there's this shift left approach, and it's about how do you push things to the infrastructure as code developer first. But no one talks about shift right. No one talks about the operational, the maintenance of your multi-cloud environment. So one of the big things we are talking to our customers is you can either start right and shift left, or you can start left and shift right. It's really doing it all. Not one thing, it's not good enough anymore. You need to have the entire thing. And some of our customers don't know where to start. And it's like, where do we start based on all the security? And kind of the main starting point is CIS benchmark. And it's a standard, very global now in the industry, that it sets the right policies and the right controls that you have to have in place across your entire stack, your Kubernetes, your container strategy, your cloud strategy. And I think that's the initial start point of the cloud from a security perspective. Now, the problem is every single cloud provider has a different CIS benchmark, and every stack within the cloud has a different CIS benchmark. And this is hundreds of requirements applied to thousands, if not millions of endpoints in a multi-cloud complexity world. So if we look at the skill set gap that we have and the complexity of the cloud and the complexity of the controls across a multi-cloud, where are you today? So one of the things that we do, for example, is we make sure that once we applied our policy as code to the infrastructure, is policy as code that can be adaptable to the environment. So as customers are transitioning to a multi-cloud environment, they need to adopt tooling and automation and technology that's adaptable to a multi-cloud world and in complexity. So I wouldn't even spend any time on evaluating a tool if the solution is not adaptable, because complexity is going to continue to grow. We cannot rely on humans to adapt for us. We don't have enough time. It's all about select the right vendor, select the right company that understands the concept. And you have to share that vision with your vendor and people that are helping you through this journey.
Absolutely. That's great. Let's get to the next topic. I think the next topic I wanted to cover was on high availability and disaster recovery best practices for Kubernetes. And I would kick off with you, Leon. Leon, what are some of the best practices which customers should be aware of when creating a resilient Kubernetes environment with multi-cloud?
Yeah, great question, Henry. So one of the first things you kind of have to step back and understand is Kubernetes as a cloud native project was really designed with high availability in mind. Having said that, if you don't take the care required to set your K8s environment up in a highly available way, because there's a lot of flexibility, you are going to potentially suffer from downtime. So here are a couple of tips that I would give folks to start thinking about. Like the first one is, you think about your control plane. So in the Kubernetes world, these are called master nodes, right? There are two important pieces. You should have multiple control plane nodes, obviously, so more than one, and they should be distributed in a way that's geographically resilient. So some customers, if they're in a single cloud environment, they will do that over multiple availability zones. And I would argue that the better configuration, the one that we're kind of moving customers towards, is control plane across multiple regions within the same cloud, or even control plane that is distributed across clouds. Now, one really important piece to notice here is that you should have an odd number of control plane nodes in any environment. And the reason that odd number is really important, in any distributed system like this, there is what's called a consensus algorithm. That consensus algorithm picks a leader. So like, which one of those 3 or 5 nodes in your environment is going to actually be the one responsible for making decisions. And that leader, and if you have an even number of control plane nodes, then it's impossible to do leader election, and you end up with what's called a split brain problem. And that's something we want customers to avoid at all costs. A cluster can run with an even number of nodes for a period of time, but really we have to recover to an odd number very quickly. Another kind of important best practice I will mention is multiple ingress points for traffic redundancy. So if you're only accepting traffic through one cloud, but your workload is nicely distributed across a couple of clouds, it doesn't matter. Like, you are going to be down if those pipes are down. So just like I wouldn't rely on one vendor for traffic, like buy my internet connectivity from one vendor, you don't want to buy all of your ingress points from one vendor as well. So we recommend a kind of a globally distributed or GSLB approach, global load balancer approach, to directing traffic to at least 2 ingress points so that you have multiple sets of load balancers that are working on the same application. And then kind of the last couple points I'll mention one really important. From an application perspective, you really want to avoid what we call singleton workloads. And a singleton workload is an application that where you can only have one instance of something running, right? So it's maybe doing something in memory, and it can't be replicated or copied. And those are bad patterns. You definitely don't want to have one of anything in any environment. So Kubernetes has this really nice concept of replica sets and a replication controller, and you want to leverage that capability. So if you're running an API service, you want to run multiple of those RESTful services or those microservices, not just a single one. So we call that avoiding singleton workloads. And the last piece that I'll mention is kind of multi-master middleware or data storage. Again, if you get to a place in an application where you have a single database that becomes a single point of failure, and that data is not replicated, and that goes back to my kind of early example of having distributed share nothing data for the data analysis use case, but that's true for transactional data as well. You want to evolve with your relational database and your big data or NoSQL data storage solutions such that the data is always replicated and there are always masters available for you to read and write from. So those are kind of the high-level best practices that I would convey, Henry.
Yeah, and it's a really daunting thing when you start thinking about it, because the problem is there's a bunch of technology we have to be aware of, a bunch of orchestration and policies we need to be aware of, but the other thing we can't forget is the people. I know we had an interesting conversation with this last time, but Leon, what are you seeing in terms of how do we deal with this from an organizational level? Because the technology is one part of it, but if the organization fails, it's not going to matter anyway.
Yeah, so...
Yeah.
Go ahead,
actually,
Fausto.
sorry, that was for Fausto, sorry.
Yeah, go ahead, Fausto.
Fausto on the organizational side.
No, and I think one of the big things is really understanding the operational side of the coin, right? We want to go multi-cloud. We want to go complete resiliency to understand recovery level. I think with the emerging of this DevOps world and GitOps emerging, where now there's multiple people touching the infrastructure at the same time and introducing just risk of operational and security risk across the board. The first thing is testing. I think we forget about how do we test our disaster recovery strategy, right? But before we get to testing, we need to understand what is our recovery point object, or RPO, which is an industry standard. Is if everything fails, this is our point back in time where we have a desired posture of security, desired posture of availability, and we need to understand that across the organization. So it's really identifying, this is my point of recovery, and this is how you come back to this point. And only very mature organizations are doing this, and it's something we have to think about. So it's really understanding that, because with this speed and this high availability, we are expanding the attack surface. There's more servers, there's more applications, but we need to always remember where something will go wrong. It's not if, but when. If we go into a build out with that in mind, it's about testing your resiliency, testing your practices, and really injecting in your operational that every automation is powerful. We could trust tools. We could trust policy as code to do a lot of things for us. That's what we tell our customers. There's good solutions out there. There's a good way of doing it. Be able to trust some of the evaluation tools that you have, because the humans alone are not going to be able to do it. So now it's time to really trust technology to get us to the next level.
Definitely. Anything you'd like to add on that in terms of what you're seeing, Leon, in terms of some of these issues?
So I think, Henry, it all goes back, and Fausto brought this up at the very beginning, it all goes back to tooling and what your skill set is in your organization. So let me give you a couple of examples, right? If you're going to build a kind of either a distributed application across multiple cloud boundaries, or if you're going to build pools of applications that happen to be hosted in different environments, what do your engineers need to know? So some folks say, well, we use Terraform scripts as the mechanism for all of our infrastructure as code deployment, so we're fine, right? And no, you're not fine. And here's the reason. Because when you look under the covers in those Terraform scripts and you look at the level of detail, you really have to understand the lowest level of the network topology in each cloud, and they're all different. You have to understand storage requirements for your application. You have to understand the differences between virtual machine instances, their performance profiles. There is, just because you have a unifying way of describing infrastructure in a common nomenclature, that doesn't mean those attributes and details are abstracted away. And I think that's one of the big fallacies with infrastructure as code. So what we're trying to push the industry towards is a couple of things. One, when you describe your infrastructure, can you do it at a higher level? In other words, can I say I would like a computer cluster or a Kubernetes cluster with these attributes and policies, but let the automation take care of the underlying details of the lowest level network topology, load balancers, how they're attached to storage? All of that stuff should be abstracted away, because otherwise it's impossible for humans to keep up with the differences between those environments. That's kind of point one, abstraction. And if you think about it, like if you go back many decades in computer science, in order to get anything feasible done, you would have to write code at the lowest level, kind of at the assembly level or at the C language level. Well, nobody does that, or very few people do that anymore, unless you're a driver. You write drivers for a living. Most people are up the stack. In other words, they use programming language like Python for data analysis and Java and other modern programming languages. And the same has to be true for infrastructure as code. We have to move up the stack in terms of level of abstraction to gain confidence in what we're actually building, right? So that's a major piece that I see.
I think that, before we move on, I think the one other thing is we have to think about the business stakeholders and move that message up too, because customer expectations are unrealistic at this point. They're all thinking 0 RPO, 0 RTO. Well, those things cost money. I mean, you can't have 0 data loss, 0 downtime unless you're building something that's highly available. And these days, a lot of business stakeholders are spoiled, and they're not willing to lose this data, not willing to lose productivity. So those conversations have to be had, because as you do those optimizations and things we talked about, none of those things can happen unless people have the right expectations of what's going to really happen when there's an outage and other things like that. And with that, I'm going to get into the last topic, which we have here, which is a very interesting topic as well, which is talking about how we deal with the cross-cloud storage environments going forward. The cloud storage market, when I look at our data, it continues to evolve at a rapid pace, and both in terms of the IaaS service, the different types of services we have available, and in terms of the third-party products that can help provide resiliency and performance advantage. Now let's kick off with you, Leon, first. What are some of the things to keep in mind when picking out the appropriate primary storage service for Kubernetes going forward?
Yeah. So, Henry, I think you have to look at it as layers, right? Kind of the lowest level storage abstraction that all of the clouds provide is what we call block storage, right? So block storage, if you think about it kind of in the legacy terms, is really a way to dynamically add iSCSI volumes to any piece of workload, any computer, any compute instance, or any container through Kubernetes that you want to set. So that's really the kind of the base layer storage solution that you can attach. Now, obviously, you have to build a file system on top of that, and there are a lot of characteristics that we have to consider. And what's interesting from a multi-cloud perspective is that everybody's block storage solution works slightly differently. And like, for example, with AWS, there is a metric for storage called IOPS, so I/O operations per second, right? How much throughput can we read and write on a particular disk or a particular volume? So with AWS, they allow you to increase your IOPS only as you increase the size of the volume. So if I order 1 terabyte of storage, I'm going to get more throughput in my IOPS than if I order just a few gigabytes. And that's not necessarily true in other cloud providers. Google, for example, lets you tune the IOPS attribute separately. And then Azure, as a third example, has actually block storage tiers where you can buy slow block storage or medium speed block storage or fast block storage. So you really want to be careful about the attributes of that kind of underlying storage layer and making sure that you're matching to application requirements. And then if I step up that stack from kind of the lowest level storage component, one of the things that you're going to need like a backup snapshot restore solution for Kubernetes specifically. And there are a number of good commercial vendors that create these type of snapshot restore technologies, and there are a number of interesting open source technology projects. So there are advantages to both. And one of the things I'll say, it's a good practice to look at your vendor base from the perspective of what are they exposing from an open source perspective, and in the worst case scenario, you kind of have a path to getting to a similar solution to avoid vendor lock-in. So I would, as a customer, look, here are the spectrum of solutions, but what open source technologies are kind of backing these vendors? And then the last kind of point I would make is be very careful of your abstracted storage model. And I'll use, like, not to pick on any one kind of storage technology, but I'll just use NFS as an example. So NFS stands for Network File Service, and it is a poor choice. And the reason it's a poor choice is because it's not really a distributed storage solution. You have lots of clients, and then you have centralized servers. And those centralized servers that manage the storage really take a lock on individual file objects. And the problem with that is you really don't have a distributed way of dealing with contention to the data. And it's but there are other models, like, for example, you could use object store model to get and set your objects in a kind of a very consistent way. You can use a distributed file system like Lustre or Gluster as well. So you should be very careful of your abstracted choice. Obviously, block is at the kind of at the core of it, but when you layer things on top of that, you really want to make sure that the layering is performant and is also adequate for distributed workloads like Kubernetes.
Yeah, absolutely. And as I talked about earlier, the more we add, the more we have to secure, which leads to the next question. How about for you, Fausto? On your side, what are some of the key security considerations that you're recommending that your customers deal with as they go to these multi-cloud storage service type models?
I mean, this comes up every single time we speak to an enterprise, right? And what I tell them is, let's take a step back, right? Let's think about what is our storage security encryption strategy. It comes down to what is your strategy. And before we actually can talk about how to encrypt and what keys should we use, let's talk about your data, like your data that you're actually storing in these services. As you scale multi-cloud, who you're allowing to touch the data, who has access to the data, right? What is the actual encryption algorithm that you're using, your key management processes? So it comes down initially to and classify the data, understand when you're hosting single customer data or multi-customer shared environment on the data storage is one thing. Once you understand that and can classify the data set, the second thing is understand your encryption algorithms that you're using, your key management, and then your access control, which is a third layer that no one ever talks about. You can encrypt every single thing. You can have your keys stored the best way, but if your access control still is not very well defined at the level of who can access even the key management, then there's nothing that can happen, right? So, I mean, and it goes back and forth. I think one of the things we saw at that Capital One breach a few years ago is, there was data that was leaked and the data wasn't encrypted. So it's about layers. It's about classifying the data, encrypting the data. Your key management process needs to be in place. And at the end, who has access to modify, change, and actually alter this process? So we have to look at the entire scope of the enterprise when it comes to that.
Great. Anything you'd like to add on this, Leon?
Yeah, Fausto made a really good point about key management. I'll add that every cloud vendor has a type of service, separate service for key management. So we call these KMS or key management services. And it's really important to understand what's under the covers there. These KMS services have special dedicated hardware security modules, so HSMs. And what's the purpose of the HSM? The purpose of the HSM is to ensure that the custody of the encryption key, whether it's a symmetric encryption key or an asymmetric encryption key, is never compromised. And so they do that through this standard called FIPS. It's a federal kind of gov standard that all of these vendors kind of support. And there's like a level FIPS 140-2. And what's important to know here is these hardware modules are kind of validated in a test laboratory as either tamper-proof, meaning if you try to physically break into this hardware, all of the data will be lost, right? Or it's tamper-evident, meaning if you touch it and you're trying to break in, there will be evidence that's audible and traceable that there was an individual attempt at a break. So without this type of kind of underlying kind of hardcore encryption technology, it's very difficult to understand the lineage of your encryption keys. And so that's one of the big advantages of using cloud service providers is that they can actually invest in these very heavy lifts to, it's a capital expenditure lift, to make sure that you have the right type of encryption service available, highly available, and the custody of your keys is not in question.
Okay, great. I think in the interest of time, I'll take one question from the crowd here, from the audience. One of the questions that came up was, how should customers think about egress costs and how they do that in terms of how they scale the multi-cloud deployments, keeping that in mind? Let's start with you, Leon, first.
Yeah, that's a great question, Henry. So that's kind of one of the interesting kind of philosophical challenges that we have is when you create a distributed application, and whether that's microservices that depend on one another, you have cloud egress costs between those interactions. Like if you have microservice A calling microservice B, you're not paying for the ingress because no cloud charges you for getting your data in, but all clouds charge you for getting your data out. So you have to be very, very very aware of where there is the flow of traffic, and are you paying an excessive amount because you might be replicating in a non-efficient way, or you might be always going over the link to access a microservice that is not clustered in the same cloud that you're where the caller is from. So there are a lot of strategies for approaching this, but at the highest level, I would say, one, you need to be aware of your topology, and you have to have constant monitoring in place to make sure that those egress costs don't balloon.
Yeah, I'll add to that. I mean, the egress charge issue is real. You have to be careful of it. I mean, just an example, I talked to a large healthcare provider in the US a couple weeks ago, and they got burned. I mean, they tried to do the right thing. They tried to create archive policies. They tried to identify their data, and they said, you know what? Medical images 4 years or older, those are unlikely to be pulled. Let's put those to a cloud. And guess what happened? Because they weren't communicating enough with their stakeholders, radiologists all of a sudden decided, you know what, we're going to pull every medical image whenever a customer comes in, a patient comes in. That wound up destroying their entire archive policy. So something that they were planning on, just a couple thousand a month, and we'll be able to archive this, they wound up getting destroyed on egress charges. So we start looking at these different real fundamental issues. I think it really comes back to a lot of what we talked about, especially on Fausto's side, in terms of we need to understand personnel and organization and build these policies and make sure that as these policies are being built, we're not going to be impacted by these changes, because there's very real consequences to changes in behavior, especially if there are things that have to deal with moving these things across. You know, even something as simple as, oh, so-and-so cloud has a better algorithm for this, let's move the data there. Well, it's not that it's not that easy and cheap to do that, because if we're doing that data move, there's going to be an egress charge moving it out. And if you decide to move back again, there's another egress charge that way. And you could wind up spending more on egress charges than you are trying to spend on just trying to maintain the data, which is crazy in itself. Anything you want to add, Fausto, on egress charge, or do you also think, Leon?
Yeah, Henry, so we'll give Fausto. I just wanted to kind of draw out an example of how egregious these egress costs are, and they're needlessly egregious. And I believe this is an existential problem for the way that clouds charge for traffic. And let me just draw out this example, and then Fausto jump in here, because I think you're pretty aware of these details as well. A cloud will charge you on, like at the low end, 8 cents per gigabyte for data transferred out. And that's kind of a starting point. It may go down as you get into terabytes of transfer. Google actually has a hidden charge where they'll, by default, charge you 12 cents unless you kind of pull a special switch So they're by default routing you over their backbone unless you say, no, public internet is fine for me, and then they'll charge you 8 cents. So there's like a hidden surcharge of about 30%. But separating that, here's the way the math kind of works. What do you think that the cloud provider pays for that same service that they're charging you 8 cents per gigabyte for? When you do the math, cloud providers pay for their traffic based on megabits per second. What they're charging you is roughly $30 per megabit for traffic that comes out of the cloud. That's the rough math. It's like 28, sometimes 30 sometimes. What they actually pay is 75 cents. So there's a built-in margin, and it's their highest margin line item when they're selling you services of something like 97% of cloud egress costs are pure margin for cloud providers. And it was one of the interesting things that we observed at Oracle, because Oracle actually has slightly lower egress costs. And we saw that people with extremely traffic-intensive applications were saving millions of dollars a month just by going to that lower cost egress charge. It's not a sustainable model, unfortunately, for anyone, and it actually prevents cooperation, and it prevents the ability, the freedom of moving data around. So I think this kind of vendor lock that these cloud providers have on data is short-lived. They might get away for it for another year or two, but eventually market forces will intervene, and I believe we will have more equitable egress going forward.
How about you, Fausto? What do you say?
Yeah, man, I don't have much to add there. I think Leon was spot on. It's understanding the data that's coming out and keep an eye on per application, and keep an eye on costs across the board, because one thing can just destroy your budget and revenue goes out the window. Just make sure that something to always pay attention to.
Yeah, I definitely agree. But unfortunately, I mean, the cloud providers like lock-in. I mean, there's really no incentive for them letting you move your data around. I think that there have been some strategies to try to use co-located storage in the middle to be able to tap into multiple clouds. But again, that's also going to create more complexity, more cost also, and also security concerns, because you have another bastion of data that has to talk to multiple clouds at the same time. So unfortunately, there's no easy part to this going forward, but it's definitely a key concern we have to think about. Any final remarks from Leon and Fausto?
Henry, thank you so much for hosting this. I think it was a great discussion. Great topics that you've brought up. Hopefully the audience got a lot of good info out of this, and we're happy to continue the conversation further.
Yeah, I think echoing Leon is, whichever vendors and whichever partnerships you're building, and now we're not in the world of just, it's not transactional anymore. It's not you go out to the marketplace and buy a tool and the tool works. It's about aligning yourself with organizations that the executive and core team understands the pain, and they're there to help you.
Thanks so much, and I appreciate it. Yeah. Oh, thanks so much. I think it was a great panel, especially because we were able to get both the cloud side of things and also security side of things. I think that's the valuable part of that. Sorry, I cut you off. Were you trying to say something else?
No, that's it. Just alignment with the partnerships, but that's about it.
Okay, great. Trisha, I'll kick it back to you.
Thank you. That concludes our virtual roundtable today. We want to thank our speakers. Thank you, Henry, Leon, Fausto, for a great virtual roundtable. It was very informative discussion. And as a reminder, we want to let you know that the on-demand version of this event will be available shortly. And on behalf of Cast AI and 451 Research, thank you for attending and have a great day.
Thank you.